In this video, I want us to take a look at how to name inorganic salts. Inorganic salts. All right. Now we have different types of salts. So we have salts. We have different types. We have simple salts. We have double salts. We also have hydrated salts. We have acidic. And we also have basic salts. But in this particular video, we are focusing on simple salts and how to name them. So the question is, what is a simple salt? Now, when we say a simple salt, it is made up of one cation and one anion. One cation and one anion. But then what we have to know is that the cation or the anion could be simple or complex. So the cation or the anion could be simple or complex. Now, when we say simple, that means it is made up of only one atom. For example, when we take a simple cation, we take a simple cation, we could be talking about just, let's say, lithium plus, or sodium plus, or calcium 2 plus. These are simple cations. What about simple anions? Simple anion. For simple anion, it also have it consists of the atom and its charge. So let's say group 7 elements, we can have fluoride, chloride, we can have something like cyanide. It is a simple anion. Okay. All right. Then how do you name salts that are simple salts? How do you name them? Now let's look at how we can name such salts. Okay. Now, the first thing you have to take note of is that you have to separate the salt into cation and anion. Okay, so when we take a simple salt like sodium sulfate, Na2SO4, the first thing you have to do is to separate the salt into the cation and anion. So with this particular salt, the Na is Na plus. These are the cations involved, and then the anion is going to be what? SO4 2 minus. Okay, so we know that we have sodium cation there, we have sulfate anion there, right? All right, so what do you do next? The next thing you have to do is to name the cation first. Okay, you name the cation first and then you state its oxidation number. So in this particular example, the cation over there is sodium. But then one thing you have to take note of is that if the cation is a group 1, group 2, or group 3 metal, you don't show the oxidation state, since these guys will have a fixed oxidation state. So for sodium, because it is a group 1 metal, we don't have to state the oxidation state. Okay. Now the next thing you have to do is to name the anion. You name the anion and then you separate it from the cation. So the anion over here is SO4 2 minus. Now, how do you name complex anions? If you watch our previous tutorial, you know how to name complex anion. You first have to find the oxidation state of the central atom. And over here, the central atom is SO4 2 minus. Okay, so for SO4 2 minus, if we represent sulfur by X, then we know that oxygen, which is 4 over here, has an oxidation state of -2 because minus 2. So x minus 8 will be equal to minus 2, which means that x will be equal to plus 6 if you bring the minus 8 to this side. Okay, so you now come back to your naming. You first name the cation sodium and then you name the anion. How many oxygens do we have there? We have 4. And so we'll say sodium tetra oxo. Since we use 4, we use tetra for 4. So we have sodium tetra oxo. And then because it's anion, the sulfur will be not sulfate. Sulfate 6. Then you state the oxidation state. So we have sulfate 6. Okay. So it is pretty simple to name a simple salt. Now, what about this particular one? LiClO4. It is the same process. The first thing you have to know is that you have to separate it into the cation and the anion. Then you name the cation. So the cation over here is going to be what? Lithium. So write lithium. We have lithium and then we name the anion. Now, the oxidation state of the central atom of the anion, which is the oxidation state of chlorine, you have to calculate it. And when we have chlorine, ClO4, ClO4 minus, then we'll say that chlorine over here is X plus 4 into brackets minus 2 equals minus. Okay, good. So minus 1. So x will be equal to minus 8 equals minus 1, and x will be equal to minus 1 plus 8, which is what? Plus 7. Okay, so we'll come back to our name and we have the cation already, which is lithium. Because it's a group 1 element, we will not state the oxidation state. So we'll go ahead and name the anion, which is tetraoxochlorine will be what? Chlorate, because it is an anion. Chlorate, and then the oxidation state is what? 7. So chlorate 7. So lithium tetraoxochlorate 7. That is another example. Now, I would like you to pause the video and try this one. Try this. We have K2, we have K2 FeCN4 H2O2. Okay, so you can pause the video and try it. It looks complex, but it is really simple to do. All right, so again, we'll have to separate this into the cation and the anion. So the cation over here is what? Potassium, which is what? K. So we're going to have K plus as a cation, and then this whole thing is an anion. Okay, that means it's a complex anion, right? Good. So the next thing we'll have to do is to name the complex anion. Now remember, we have 2 of the potassium here. That means that when we take it, we'll have 2 of the K plus. That will leave a charge of what? Minus 2 on top of the anion. So how do we find the oxidation state of ion here? Ion we don't know, so we call it X. And then we have Cn, cyano. And this one is a charged ligand, which has a charge of minus 1. So we have 4 into brackets minus 1. Water is a neutral ligand, so we have 2, 0. Neutral ligands have a charge of 0, okay, equals minus 2. So X will be equal to minus 4. This is 0, and so we have equals minus 2. So X will be at minus 2 plus 4, which will give us what? Plus 2. So we know that the oxidation state of the central atom of the anion is what? Plus 2. So the first thing we have to do is to name the cation, which is potassium, and then we name the anion. We name charged ligands first before neutral ones, okay? So we have tetracyano, how many water? 2. So diaqua, and then the ion when it is in an anion form, we call it what? Ferrite, okay? We call it ferrite. So tetracyano diaqua ferrite, ferrite 2, okay? So that is what the name looks like for this particular compound. Now you observe that all the examples we've been talking about is made up of a simple cation and a complex anion. A simple cation and a complex anion. So what do you do in a case where you are given a complex cation and a simple anion? So let's just say we have complex cation and a simple anion. Complex cation and a simple anion salt. So let's look at some example. So the first example, let's take copper H2O. We have copper H2O 4 and then Cl2. So how do you name this particular compound? We'll have to name the cation again first before the anion. And so naming the cation, we have water attached to copper, okay? So water is aqua and it is 4, so we call it tetra aqua, and then the central atom copper, and so we call it copper, then the oxidation state, okay? Water is a neutral ligand, so it's 0, and then we have Cl2 here. When we separate it, it will be what? Cl minus, and we have 2 of them. So when we take it away, we have a charge of plus 2 on top of the cation. So we know that the oxidation state of copper is what? 2. Okay? Then we name the simple anion, which is the chloride. So one other thing you have to take note of is that when we have copper as a cation, we state it as copper, okay? But if it is an anion, we call it cuprate. Cuprate. So if it is an anion, we call it cuprate. All right. Okay. Now you can try this example. We have nickel. We have nickel into brackets NH4. Sorry, NH3, and we have 4 of that. Then we have Br2. So what will be the name of this inorganic salt? All right, your guess is as good as mine. We name the cation first, and so we have 4-amine. So we call it tetraamine. We have tetraamine. Then we have nickel. Tetraamine, nickel. The oxidation state of nickel is what? Plus 2, as you can tell. NH3 is also a neutral ligand, so it is what? 0. And then if you separate the bromine away, we're going to have a charge of plus 2. So nickel is what? 2. So tetraamine nickel 2, and then the anion bromide. Good. Now, one last one. You can pause the video and try this. We have FeCl2, NH3, 4, all this in the square bracket, and then we have CN. All right, so what will be the name of this compound? Now, again, we have to name the cation first, and we need to know the oxidation state of ion. We need to know the oxidation state of ion. All right, so ion here is what? X, and then we have chlorine. Chlorine has a charge of -1, so we have 2 of -1. Ammonia is neutral, and we have 4 of that, so 4 times 0. And then if we, sorry about that. All right, so we have 4 times 0, and then what will be the charge over here? The charge over here is going to be what? +1, because Cn has a charge of what? -1. So equal to what? +1. Okay, so x minus 2, this is 0, equals what? +1. So x is equal to +3 if you take the -2 to the right side. Okay, now once we know the oxidation state, we can go ahead and name the cation. So the cation is going to be, remember, charged ligands are named first. So we have chloro. So we have dichloro, we have dichloro tetraamine, tetraamine ion, tetraamine ion 3 from the oxidation state over here. So ion 3, and then the anion, which is cyanide. So that is the name of this particular salt. Now, our last group of salts we'll take a look at is the group that has both complex cations and complex anion. So we have complex cation plus what? Complex anion. All right, we'll take some two example and we'll take a look at how we can name them. Okay, so we have zinc H2O, 4 SO4, right? So you can clearly see that we have this part, as the cation, and then we have the sulfate as the anion. Okay, so what do? We name the cation side first, and so that is going to be zinc. Now remember, oxidation state of zinc, water is neutral. So when we separate this, we're going to be having ZnH2O 4 2 plus plus SO4 2 minus. Okay, that is what it looks like. Now, so we'll have to name this cation first. Now, zinc over here is X, water is neutral, so 0, and equal to what? +2. So zinc is what? +2. So the cation is going to be tetra aqua zinc 2. Okay, tetra aqua zinc 2, and then we name the anion. What is the oxidation state of sulfur? Sulfur is X plus 4 into brackets -2 equals what? -2, and so X is equal to -2 plus 8, and so X will be +6. So we have 4 oxygens, and so we have tetra oxosulfate, tetraoxosulfate 6. Okay, so this is one example of a salt that is made up of a complex cation and a complex anion. Now you can try this last one before we go. We have FeCl2, NH3 4, and then we have NO3. So what do you think could be the name of this? So straight away we have to name the cation. So we have dichloro because chlorine is a charged ligand. Okay, dichloro tetraamine ion. If you calculate the oxidation state, you get 3 ion 3, and then the anion is what trioxonitrate. Trioxonitrate. Oxidation state of nitrate is what 5, so trioxonitrate 5. Now I hope this video helps you in preparing towards your class test or your exam. Remember to like and also share to your friends. Thank you.